All right. Hello, everybody, and welcome to another episode. The final episode of 2025. It's Friday Night Codin. No, it's not. It's Advent of Code in Kotlin, of course. Hello, everybody. Glad to have all of you back. It's wonderful seeing all these hellos at the beginning here. Yeah, it is. It is a little bit bittersweet that this one is the last stream, but of course, there's still more Advent of Code to go for everybody, and we'll make sure that we'll make today a good one. Yeah, it was day 5. We got to puzzle once more. How did it go for everybody? How was the experience? Did you enjoy today's puzzle? Did you come up with a clever solution? Brute forcing? Are we struggling with the music? Because I think I also hear that. Let's see. Very interesting. Music is breaking my voice. What a strange technology. Hold on, let me see if I can fix this by reloading my end. We'll be right back. I don't know if this makes any difference, but we'll see. Maybe there's music, maybe there isn't. Otherwise, it's just you and me. I think it might. Okay, I think it might just be you and me today. Well, such is the wonders of technology. We'll still manage to make it a cozy one regardless. That's fine. Am I on Linux? That's audio driver slander, and I will not stand for it. No, I'm on Mac OS, and I even have it all set up with Chrome and everything, specifically just because that was the one that was supposed to be optimized for in our broadcasting. Oh well, but things are as they are. Well, we'll still keep the Advent of Code vibes going, and we'll of course just provide. Okay, well, I guess maybe instead we're meeting Olaf, and
Hi there.
we're meeting my screen in a second as well. Olaf, it's so good to have you here.
Thanks for having me. Yeah, it's a wonderful show.
Right? Maybe you want to do the the overview this time now that we've already brought you on here. Hold on. My screen share is doing something funny as well. There we go. Today is the day. It's the day of cursed technologies. Already bodes well. Olaf, do you know what we're doing for Advent of Code 2025?
Today it's day 5. That's what we're doing, if you mean that.
That's right. I was
But we also
the whole campaign thing that's going on.
Of course, you can all participate and share your code that you do in Kotlin.
Exactly.
We've got leaderboards for you.
We've got leaderboards, we've got templates, and we've got ways for you to win prizes. Look at this. We made the best of it. We'll make sure that we put these links up here as well. There's also a tiny bit of a special treat for all of you who have missed yesterday's stream for some reason. Of course, all of our streams are recorded, and you can find them in the live tab, just like how you found this one. Make sure this says subscribed, by the way. But we've actually turned the episode that we've done yesterday with Roman Belov into a standalone video that specifically cuts down on some of the fluff and is really about all of the cool stuff and the visualizations that we've done. So if you've missed yesterday and you want to see a little bit more about Kotlin notebooks and how that relates to Advent of Code and problem solving, just find that video afterwards. Give it a like, share it with your friends so that it gets recommended by our almighty overlords, the algorithms. Very good. Olaf, how has your experience been with Advent of Code 2025 so far?
It's been a mixed bag of things, just like every year. And as we all know, this year, sadly, we only have 12 days to puzzle, meaning we are almost in the middle of the whole thing. And as we were all like eager to see how the difficulty level would change over the days, I must say, just like every year, I feel it's still day 5. It's on the same level, I think, that we had in the former years. So let's see whether it gets more difficult sooner or later. I have no idea. But so far, I struggled with the exact same things I have struggled with every year. Every year, December 1st, the puzzle is easy, but you are sore. You didn't do this for 1 year. So you do the most stupid mistakes you can think of. So yes, I've done fine. I've solved it, but I wasn't happy afterwards when I took like half an hour for something that could be solved in a minute.
Yeah, I mean, these things they very much happen.
Yeah,
it's quite easy to get a little bit rusty because let's face it, the day-to-day oftentimes does not look like an Advent of Code puzzle, for better
correct.
or worse, I suppose, but mainly for better.
Yes.
Yeah. I have to say, I was actually very surprised. I was a little bit nervous regarding the fact that you never know what Mr. Wastel throws at you, and with the new compressed schedule, I thought maybe he was gonna really crank up that difficulty quite quickly. But I think he kept it on a level where even if you're just learning a language, there's still a good chance that the algorithm won't be the limiting factor after a little bit of puzzling, putting in a little bit of brain power.
It's important for him to do that in that sense that he doesn't want to scare people away. I mean, Advent of Code, after all, is a very good tool to learn new skills, to learn languages, as you said. So it would have been a tough thing if he cranked up the difficulty too quickly. He doesn't want to lose people, and I can totally relate to that. Definitely.
That makes a lot of sense to me too. I am curious though. I mean, tomorrow is Saturday, so depending on whatever twisted logic one might have, surely people have more time to puzzle, right? So maybe tomorrow is where it gets tricky. But that's where we're off with the live stream, so the stress level is a little bit lower on my end. Okay, very good. Let's take a look here. Main challenge for part 1 was parsing into suitable data structures. Part 1 was simple. People are already talking about ranges and ranges. I'm repulsed by iterative code, but luckily I could just slap a yield in the middle of a for loop to make it pure and functional.
Okay, we can discuss that.
Yeah, lots of opinions going on. Yeah. Also, I can address the question of why only 5 videos and not 6, because it's the weekend, and I have plans. Sorry. Okay, very good. But today, my heart belongs only to Kotlin, to code, and to whatever solution you've written up, Olaf. So let's get into it. Hat goes on.
I got a hat myself.
Amazing. I love the preparedness on my guests this year. It's truly magnificent. It's so much festive spirit.
You see this one here, the delegate one? It was the closest to celebrate that I had.
That's very good. I like that a lot. That's amazing. Okay, well, we'll dive in. For our very last problem, still continue to be sponsored by Kotlin by JetBrains. It is day 5, cafeteria. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put the wreaths up in the dining hall. Resolute in your quest, you investigate. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask what's going on. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, they give you a copy of their database, your puzzle input. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. For example, 3 through 5, 11 through 14, 16 through 20, 12 through 18 are our fresh ingredient ID ranges, and our available ingredient IDs are 1, 5, 8, 11, 17, and 32. The fresh ID ranges are inclusive. The range 3 through 5 means that ingredient IDs 3, 4, and 5 are all fresh. The ranges can also overlap. An ingredient ID is fresh if it is in any range. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as follows. Ingredient ID 1 is spoiled because it does not fall into any range. ID 5 is fresh because it falls into range 3 through 5. ID 8 is spoiled. ID 11 is fresh because it falls into range 10 through 14. ID 17 is fresh because it falls into the range 16 through 20, as well as the range 12 through 18. Ingredient ID 32 is spoiled. So in this example, 3 of the available ingredient IDs are fresh. Process the database file from the new inventory management system. How many of the available ingredient IDs are fresh? And we can take a brief look here at what this example input looks like. Numbers with a lot of digits. And, well, ranges, couple dozen ranges, couple hundred IDs. Okay, very good. Olaf, as usual, the question now is, what went through your mind?
Of course, as I said, I was waiting for the difficulty to increase. That's a bad habit, I know, but I was looking for what could spoil things here. So I was looking so hard that I didn't really start to do it the straightforward way. For example, I didn't look at the data that it was like big numbers. So my first approach was integers, and you can all tell that integers don't really like these large numbers. And I didn't look at them. So yeah, well, but I thought like, okay, it sounds reasonably easy to do. We have a list of ranges that we have to parse. Parsing is in this situation, parsing is, I guess, one of the harder jobs. Easy, the rest is relatively easy. I mean, when Advent of Code has these puzzle inputs that are comprised of 2 sections, I mean, especially newbies to Advent of Code, they might struggle a lot with separating the input data easily. Yeah. So of course, if it's that simple, you could manually copy paste the 2 portions into your code also. But if you have any reading in the background, like file system that reads the puzzle input, you have to write something that separates 2 sections of input. Yeah. And for those of you who have seen my solutions in the past years, I got this library that I've written myself that basically does the download of the puzzle. And by the way, that is the reason why I almost never look at the input data. I don't really see it. It's downloaded in the background and it runs my code. And then, of course, it fails with such things that the numbers are too large for integers. Yeah, that's the problem here. But on the good side, it has ready-made values that provide the sections of input data. Like section 0 and section 1 are my 2 sections here. And I'm writing code that processes each of the 2 sections separately. Yeah.
Okay, very good. Well, shall we see it in action?
Yes, we can do that.
Well, let me try to move on over here to your screen share, and we'll see how this goes. Hey, we're still here, but this is not your
Not
screen.
my screen. That's my screen.
This is your screen. Very
Oh,
good.
yeah.
Okay.
I hid all of the things that could spoil things now, as you can
Perfect.
see. So as I just told, the input sections, they denote my first and my second input section. So that's how I start. And I really, really like to give things a proper name right at the beginning. So I know that this is not good for speed coding. I don't start with ABC, XYZ, and stuff like that. I'm taking the time, even in a bit of code, to give those things proper names. And as you can see, the parsing of a separate section, like the section 0, the first section, provides the input lines. And as every range that we have to process resides on one line, we just use the map operator. And within each line, we split by the minus dash that separates the beginning and the end of the range. And then this is a cool trick I always like to use. If you have something that provides a list or a collection, you can basically access the components. I think you can only access the components on a list because collections don't provide indexed access, but I'm not really sure. So you can basically split the thing in two parts and then take A, B and just convert them to the long values and use this neat little infix operator to create a long range. So my data structure from the very beginning is a list of long ranges, which denotes the fresh ingredient ranges. So that's pretty easy. The other section is a little bit easier even because you just go to the section and take every line and map it to a long value. As I said, if you screw this up and start with int, yeah, you're basically down to rewriting all of that. And if I had one wish, in languages that are not typed, like if you do this in Python, you never care about that. It basically just works. And because of the cool feature of Kotlin that you basically like all of the sections where you can leave out. So because this is type inference, you don't specify as a list of long. So coming from Java many years ago, this already is a huge bonus because if you had to type all of the types, then you would have to change more pieces of code in such a situation. But sadly, these too long invocations, there is no way I know that I can easily switch out the types in one go. Of course, search and replace, but
yeah,
yeah, that's the point here.
that's very true. There are some other languages where your type inference is just a lot more aggressive. I believe Rust is one of those examples.
Okay.
The problem is that in those situations, like it's always a trade-off. You can do that, but then people will start writing code that has crazy like where the inference of a type happens very far away from where the thing is actually declared because like the constraints only start applying later, and I found that quite hard to reason about as well. So that's just always the trade-off.
So what you could do, of course, is you could write an extension function that basically does something like toInt and use that extension function. Like I could go here and say num because I know it's a number. And if I did that everywhere in my code, of course, if I came to the conclusion it doesn't work with ints, I can go here. And once I type too long here, everything is fixed already. Yeah.
And then for return types, I guess you also need a type alias that.
Yes. So
yeah,
not easy. Yeah.
Sure.
But we don't want to go into the problematic portions of this puzzle. I'm already feeling I'm looking for problems where there weren't any problems, just to have something to tell you.
But that's perfectly fine. By the way, I like the point with the destructuring part. This is actually something you can do on all data structures that implement the component operator function.
Yeah.
So you can even do this for your own things. If you're coming up with something, you can just have component 1 and component 2 functions, and they will do exactly like they will allow you to do the same kind of destructuring.
And by the way, I'm looking for a way to prove how this destructuring works. In many other situations, like for the invoke operator and many others, there is always a trick. For invoke, you can press down your command key and go to the parentheses, and you can jump where the invoke function is. But for the component operator functions, there is no IDE section where I could click here to jump to component 0 or component 1 and component 2. At least I don't know how to do that.
I can't hover over the parentheses. Yeah, okay.
Yeah,
Interesting.
you can't do it here. It's not here. Yeah, okay. So, but now let's go for the solution of the part, shall we?
Sure.
Okay, let's unfold this here. So the cool thing about my approaches, they are almost always functional. I love to do it that way, even though sometimes it hurts. But this is on a level where it doesn't hurt, because as you know, the puzzle set really it's just like the puzzle set. Count the number of ingredients, so you can basically follow along. Now we are counting the number of ingredients, and if I recall correctly, even the problem statement said where any of the ranges include the ID. So
Yes.
of course, where any of the ranges include the ID. I think this is a wonderful way to show that functional programming shouldn't scare anybody away, but basically tell a story like this. Yeah. So what are we doing? We count the number of ingredients for which there is any range that includes the ingredient ID.
Yeah.
That's all we have to do. And it works like a charm, and it basically does what you think it does.
I mean, it's wonderfully excellent. Let me show you something here for a second. Let me see if this change works. Hey, look at this. Here's my code. Here's your ingredients. You count where for any fresh range the ingredients are in that range. Looks familiar? Sure,
Yes,
sure might be. I have a slightly I did slightly overcomplicate it on my end here, or well, I complicated it. I'm not sure if it's overcomplicated, but it's complicated. For the parsing, I still use the destructuring syntax. I just decided to do the destructuring separately rather than having it back here. I also don't have any cool function to get the sections. So instead, my input is simply split on 2 new lines, which is the, I think, semi-canonical way of making sure that, well, it splits on an empty line between the segments. And then you can just kind of pull out the 0th element here, as well as the first element. So nothing really special here. I did, again, because I decided to build my own data class rather than go directly for a long range, because I did not know what might be expected of me. I wrote this up, but I still want to have the nice syntax with ingredient in range. So I just provide an operator fun contains that takes an element, returns a Boolean, and just does the comparison on the underlying long range. So pretty much exactly the same. Looks, yeah, like a carbon copy, effectively.
And we didn't talk about this before.
We did not. We did not.
No.
First time we're exchanging information here.
Yeah.
Oh, very, very good. Very, very good. There, I assume your sections implementation is the same as just splitting onto new lines.
I have a section delimiter, and guess what? That's my section delimiter.
By lazy.
Yeah, everything. I mean, this is lots of things. I can basically ask for give me whatever I got here. It's so much code, hundreds of lines.
It's so much. It's so dense as well.
Yes. So I can't even tell you. This is years that I've written this, years before. So
I remember you mentioning this like last year. You were saying that one of your main challenges is remembering what's in the library.
So look at this. This is my puzzle input, and I also have a class for that. So every puzzle input comes in as a raw string. This is what you download, what you can put in there, and then you can have it as lines. That's the most simple thing. You can have it as a grid. So for all of the 2D puzzles, I immediately have a grid. You can have it as integers. This is basically just parsing every line, but it's also including code that says, do I have only one line? Then take the integers comma separated. If I have more than one line, take it per line. I can have the same thing as longs. I can have the sections down here. And every section, this is the cool thing here. So you see the type of the section. Guess what? Every section itself is a puzzle input again. So in the section, I can again say grid. So if the section is a grid, I can say section 2 grid, whatever.
That's okay. That's pretty smooth.
Yeah,
I like it.
I encourage everybody, if you want to have this, don't get it somewhere, write it yourself, because that's the only way you remember this and learn it.
Yeah.
Yeah.
And it's an extra, it's a bonus fun puzzle.
Yes, definitely.
I think we've explained part 1 to death. I don't think there's anything else that's worth discussing on this one, is there?
I tried the same thing with a non-functional approach. I tried to do something like, what would I do if I didn't know functional programming? And I would do something like, I need a variable that is the counter that starts at 0. And then I would go for, see, AI helps me again. Now, this is the cool thing in 2025. AI tells me you can loop over the ingredients. Yes, we take that. What should we do? Well, if any, okay, that's taken from my code actually. So I didn't want to do this, but I had another one for J in ingredients. No, I didn't do this. So
I hope not.
No. What I wanted to show is if I wanted to count, I go for the ingredients, and then for if, no, I would go for
want to
range,
loop the fresh ingredient range. Yeah.
Fresh ranges. See, and this is what AI told me. I just hit tab and got this. Yeah. And guess what? If you run this code, there is a bug in there. Can you spot the bug?
Hold on. If I in R. Oh, I don't think I can spot it. Hold on.
Yes, I ran that code and it doesn't count correctly. Anybody who sees it immediately? I mean,
it doesn't break. It doesn't break the inner loop. Oh yeah, that makes sense.
And the point is really like, this is something you run into especially if you take AI hints and say tab, looks good, and you run it. And the first time I ran this, it was like 4 instead of 3. And I was like, why is it 4? Why is it 4? So for everybody who doesn't see this now, you have to, of course, break, because the problem is, the problem really is that the any part in our functional solution, it does everything for you. It says, if there is any range that includes it, we have all we want. My hard-coded way to do this, if I don't do the break, I count every ingredient range that includes the ingredient. And so I can overcount, because it's only one ingredient and it could be in multiple ranges. And if you miss these things, you are off by 1 in this demo case. And off by 1 is always like, wow, then you got like, oh no, where did I do this off by 1 mistake? Yeah. So what I really like to do is go into here and see how it's programmed in the standard library. And you see that it just loops. And this is the break that they put into the standard library. It does a return in the loop when there is one predicate met. So basically, if you use these functions, you make not that many mistakes, at least for counting.
Very, very true. The whole counting and any combination, I think, is a lot smoother than writing it up yourself.
Absolutely.
Okay, well, in good old AOC fashion, I should now probably ask, well, how hard could part 2 possibly be, right? So let's find out together and dive right back into part 2. The elves start by bringing their spoiled inventory to the trash chute at the back of the kitchen, so that they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID ranges consider to be fresh. An ingredient ID is still considered fresh if it is in any range. Now, the second section of the database, the available ingredient IDs, is irrelevant. Here are the fresh ingredient ID ranges from the above examples. We've already seen those. The ingredient IDs that these ranges consider to be fresh are 3, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So in this example, the fresh ingredient ID ranges consider a total of 14 ingredient IDs to be fresh. Process the database file again. How many ingredient IDs are considered to be fresh according to the fresh ingredient ID ranges? And again, they're pretty large numbers. They might also potentially be pretty large ranges themselves. That's always very hard for me to spot intuitively. Okie dokie. Olaf, thoughts?
So first of all, you see that you get less input now. You can ignore the second section that we dealt with before. So it doesn't seem to get harder. And that was exactly what, so I was like, again, looking for, did I miss something? Is this really what they want us to do? But of course, let's look at this. So what's the task here? If you would put that in different words, basically mathematically, we have an arbitrary amount of ranges. And the question really is, can you merge these ranges so that you don't count twice? So if you look at those ranges in the example, it is like the first range includes 3 IDs, 3, 4, 5. The second one is 5 IDs. So basically, you know, it's like the end minus the beginning plus 1 always. But you can't just sum up all of those because you would count the, let's say, the 14 twice, because it's also in the last range 12 to 18. So the mathematical question really is merge all of those ranges so that none of them are overlapping or even including themselves. That's basically what we have to do. And then
sense.
it's all a matter of summing the sizes of the ranges. And we've already seen in the puzzle input, we are not dealing with that many ranges at all. It's like 2 pages, 2 screen pages, 3,
Yeah.
I don't know. It's not that many, not a number that would scare anybody.
True.
So the only point is the numbers themselves are large. So it wouldn't be a wise idea to merge these by going into the specific IDs. That's something you should see very quickly if you don't want to go in that direction.
Yeah, counting all of them might be hard. Like just going var count equals 0 and then count plus plus, not quite feasible potentially.
Yeah. So and you would need to have some storage for every ID, whether you have already counted it or not. That's basically the problem. So if you think about it, if I start with the first range and I would like to note that I have counted 3, 4, and 5 for once, I would need a data structure that is like a set where I put the numbers in, or even worse, I could take an array or a list and or a map, any data structure. But the problem is if you have large numbers and huge ranges, it's not about the large number, it's about the many numbers in the range. You would easily need too much memory to do this efficiently in any way. So it's a mathematical thing. How do you merge a number of given ranges? That's the question we had to solve here right now.
Okay, so let's dive in. I'm going to throw your screen back on here.
Yeah.
Whoop.
So let's look at the part 2 here. I mean, if I open this, let's see, it's already opening. Let's start this bit by bit just to make it a little bit more exciting. So at least the way I know to merge ranges is if you think about the ranges and if you sorted them by their beginning. So that's a precondition for many algorithms so that they can really work efficiently. Take all of the ranges and sort them by their starting number. So if you think about it, the 3 to 5 is the first one because it has the lowest starting number. Then you would have the 10. Then you would need the 12. So if I do the sorting manually now, what I do here is I sort them basically in this order so that I have 3, 10, 12, 16. Now. And then you can see my next operation, having the ingredient ranges sorted by their beginning. So the reason why this is a cool feature, if you do this, the list of ranges holds a very important predicate. If I go from the first to the last, I definitely know that the last one cannot be in front of the first one. So the 16 is always guaranteed to be bigger than the 3. So the only thing that can happen is that the next range is larger or equal. That's what could happen. And if you put them on a piece of paper and write this down, visualize this a little bit, then you see that in order to get them to a lower amount, basically to merge them correctly, if we do this by hand, 3 to 5, okay, tick in the box, we can remember 3 to 5. And then we know from this to the next starts at 10. So all I have to do is I see that there's a gap. And because there is a gap, and because I know that the 10 is the next following this specific range, I know for sure there is nothing with a lower number than 10 because of the sorting. I can already guarantee that 3 to 5 is a fixed range I need to keep.
Mm-hmm.
And the next one I need to keep for now is the 10 to 14. So I keep that in mind. Now that I encounter the next one, always looking at the next one when I'm done with the previous one, I see that the 12 is within the range that I'm currently looking at. So I see the 12 is smaller than the 14. So these overlap. And now the easy thing is, because I know that this is sorted already, I can say they merge into one range from 10 to 18. I just take the last of this one. The only thing I need to check is whether the 14 is bigger than the 18. That's the only thing I need to take care of, because it could very well be that this one here is like totally within the other one.
Yeah.
So that's the logic. How do we program this? Well, the easiest way I know how to do this is a fold operation. We've discussed fold many times already, and I love it. Fold is one of my favorites. The cool property of a fold is when you write it, that by defining the initial value, so the nucleus, where you start doing your operation, whatever you type here will become the type of the result. So because we know that we want a list of ranges as the result, we already know that we have to start with an empty list of long ranges. This defines my outcome. And now we have to think about what I just described visually. Every fold operation takes accumulated result so far. That's what conventionally, that's always the accumulator, and it takes the next element. In this case, it's the next range. So there is one small condition that I need to tackle first. When the fold operation begins, we start with an empty list. So that means if I look at the accumulated list of long ranges that we have, there is no previous. We start empty. So if I try to access the last, I use this last or null. And when there is no previous, I know it's the beginning, I can immediately return with the list of this very first range.
Mm-hmm.
And once this special case is handled, we are in my described procedure. We always look at the previous and we compare it with the next. And the cases I just described, I try to do this with comments here. So if the next one's first number is bigger than the previous last plus 1, that's very important. We need a gap of at least 1 here. Then they don't touch at all. What I do then is I take the so far accumulated list of ranges and I have to add the next range to this list. And that is my new accumulator. You notice that this is an expression here. So when is the last expression of the fold block? So whatever I put here becomes the next accumulator. So then we have the next case. They are overlapping, what I just described in the demo input. So the B range starts within the A range. You can say that if you check the last of the next one, this one here, that's the check whether it's completely included or just overlapping. If the next one's last value is bigger than the previous last value, then we need to merge the two together into one new bigger range. So this is the core merging procedure. What do? I take the ranges that I have so far and I drop the last one. Dropping here because I'm always working with immutable data structures. So you see it's an empty list and not a mutable list. It's very bad practice, if you ask me, to use a mutable structure in a fold operation that can break. So I don't like that at all.
Very much so.
it works perfectly on immutable structures. So I have to drop the last one because it's irrelevant, and I add a new one. So basically, this is a replace of the last element. And the new element I put in there as a placeholder for the two merged intervals is basically coming from previous first until next last. That's the merging. And then we have only one more situation to cope for. If the next interval is completely within the previous, then all I do is I keep the accumulator and I don't add or remove anything. That's all we have to do this.
Yeah, because it's already mapped out. Yeah.
So there is one thing that I also, it's not the first time that I had a problem with this. You might wonder what's that plus element.
Oh, I was actually about to ask.
Yes. So if you come from using Kotlin operator functions, the first thing you type is this.
Yeah.
And voila, that's what you get, compile error. So this is something, I forget this every time I work with these things. It's really tricky here. Why does this happen? So when I have a problem like this, what I do most of the time is I put a variable here to see what type am I dealing with. Why is this wrong? Because I don't like to see everything in red. This is not working for me. So what I do is basically do this refactoring just to make it a little bit more visual. So the list is wrong type, but it's a list of any. So why on earth is this now a list of any if I take a list of long ranges and add a new long range? Well, the reason is if you look at the operator function plus, it resolves to adding something to a collection with an iterable of the type of the collection. So this is a little bit more intricate here. The problem is the list of long ranges. So long range, I consider long range to be my T.
Mm-hmm.
So I want to add one element, but the function plus actually takes more than one. It's an iterable here.
Yeah.
Why did the compiler choose this function? Well, the reason is basically, if you look at the long range, every long range implements a few interfaces. Let me try to find the one. This one is not the one. I think it's that one. Nope. Then it's this one. Comparable progression.
It's right there.
Here, there it is. So every range that you take is also an iterable. The iterable provides every element of that range.
Mm-hmm.
And now the compiler, if I do this, the compiler chooses the wrong way to think about this. It takes my collection of long ranges and adds all of the numbers of the second one. Basically, the type T gets resolved to any and not to long range. So it's a very handy trick to know that there is a plus element. This forces, this function forces basically the correct thing. And if I look at the implementation here, this is what it does. It takes the type T, and now it's easy that the type T needs to be a long range in my case. Yeah. That's basically, that was the hardest part. Again, like took away, let's say, a minute or something to fix this again.
It's interesting, by the way, that it seems that using plus element once seems to be enough for the second one to resolve correctly.
No.
I could have sworn for a second there was, okay, never mind, sorry, my bad.
Yeah.
Makes perfect sense that it wouldn't, which is why I was so confused. I was just looking at the wrong corner there. Okay. Yeah. I mean, another
generic types
quirk.
are always a mystical thing. Generic types, sometimes it's really hard to follow along what a compiler does when it comes to generics.
Yeah, for sure. Yeah. Okay,
very nice. Once we have done this, the only thing we do is we sum the sizes of the ranges. That's basically it.
Is size a property that just exists on a long range?
Yeah, yes. And it's basically implemented the same way you did it.
Yeah, how very lovely.
Yeah.
It's great when everything's already there out of the box. And then one can still have the joy of the re-implementing it anyway.
Yeah.
Very interesting. Very cool. Now, I understand that you have also visualized this approach. Is that right?
Yes, what I did, I was really inspired by that video you did yesterday. And it's a cool thing that you pulled that out and did a new one that just goes into Kotlin notebooks. So what inspired me yesterday was, of course, the cool way to basically use the notebook, but also something that I didn't do that much in my past is like use AI for stuff that you are not willing to write yourself. So what I did this morning is like I basically took JetBrains AI engine here and I said, can you write me some kind of a visualization for what I'm doing here? And interestingly enough, it's really cool if you just provide. I'm solving a puzzle here. It's about merging ranges. What could we do? And it comes up with something that just runs. And I mean, vibe coding, that's what they call it. I don't look at the code. I don't care at all what the code is. This is a situation where I would totally recommend doing that. Anybody who's doing advent of code in Kotlin, go to that AI tab and say, give me some idea on how to visualize that. And it comes up with something. You need to specify a few things like I did do it as a JPanel, just like you did yesterday in the stream. So if your project is set up with Compose, it might also work with Compose, but JPanel is easier, I guess, to just have available in a JVM project. Yeah. So
Sure.
you can easily ask for it. But you have to share now to see what the AI came up with.
I'll hop
And then
on
it's
over.
all about prompting, basically. So I took the first solution and I prompted it to do the layouts a little bit different. So you can see that it's now simulating how the ranges are sorted.
Hold on,
Very
I'm
good.
moving it all into.
And it's very slow, but there is a slider. It was too slow for me, so I said, put in a slider, and it did. So you can increase the speed.
Ooh, go
So
a little
first
bit
step is
faster.
sort the ranges. So you see in my code, I just say sorted by. I don't know which algorithm, but this one here is just simulating a sort, and it's doing a sync sort. But that's probably not what's done in the Kotlin standard library. But it shows you how the ranges are put into the correct order. And then the merging algorithm pulls down the ranges one after the other and either joins them or starts a new range that persists.
Yeah, so we can really see some of them. I'll do that again. I'll try to skip over parts of this and then really slow it down at the end there. We can see that some of these bars are kind of like growing as like
Yes.
more of the ranges are blocked in. Other ones
Yes.
they just draw a new square, so we got a lot of
Yeah.
tiny squares next to each other.
And I did this in the beginning with just the demo data because it's easy to see and it's huge bars and 5 numbers. But then I wanted the real thing, and it, of course, didn't look good. And I just said, can you please adjust your code to cope with large numbers? And it worked out of the box. It just did.
So very cool. It's really, I mean, it's really elegant. And again, like for whipping up a visualization after you've done the puzzle, you've done the brain work. This is kind of it's almost a cool way of like rewarding yourself in a way as well.
Yeah. I can totally see that the future is going to be like full of visualizations and animated GIFs in social media. I don't know. It's like mind blowing.
Yeah.
And it doesn't matter whether the code is good or not. I mean, I even saw like warnings, squiggly yellow lines that I would never accept in my professional life in code that does anything that is like worth doing the coding. But for this kind of stuff, who cares about a compiler warning if it just works?
Yeah, exactly. It's just fun to have something out here. This looks, yeah, it's really cool, and I think it gives really the intuition of the approach.
So the prompting that I did included things like, can you drop the bars down to the merged result, for example? And that's when it came up with these floating things. That was some prompting I did. So prompting is really a cool way to do this.
Now it's all in the ideas and all the
Yes.
in the taste that you gotta have, and then
I mean,
the
if you
machine
have
can
this
help with the
idea
execution.
and you want to code it yourself, like having the idea is a 10-second thing. But if you wanted to code this by yourself, I mean, you can look at the code. I have not done that yet. I just see that it's full of timers and kicks and stages and stuff. And to be honest, I don't care. It's like, who wants to know this? It even uses deprecated integer constructors that I've never seen.
like a real proper deprecated ones. How interesting. But again, it cooked up something that ended up working.
Yeah.
And if it's between the visualization not existing or the visualization existing, we take those. That's really cool.
Absolutely.
It's really gorgeous. Now there's something quite funny, which is that I solved this problem in a quite different way. Well, maybe not quite different, but somewhat different than what you did. Let's hop on back over here. You are gonna get a heart attack probably because it does not involve a fold. So I'm very sorry for that in advance. But let's walk through it. So this is roughly the code. I also needed the precondition that everything is sorted. That so far so good. But instead of merging ranges, I figured what I really want to do is I'm just interested in the count, right? Like I actually just want to know how many elements are there. And if all of the ranges were distinct, this would be a super trivial task. You just you just sum everything up. It's just that there are two special cases. There is once the special case where one of the ranges is completely within the previous range. That means you add nothing. And there's another case where you kind of have an overhang. So, like I said, if it's a completely fresh, like if it's a completely new range, it doesn't have to be spaced, but it has to begin further down the line from the last range that we've counted as fresh. Then we add all of the elements and we say, well, the last fresh element that we've seen is the end of that new range. If it's smaller than that, then we kind of, but it does kind of like overlap potentially, then we might have an end that kind of pokes out. So we effectively just check, is there an overhang? Is there something off to the right? And that might be zero or negative. That's the case when it's completely covered, but it might also be a positive value. And then we need to add this overhang to our count. Everything else we would be double counting. And of course, we need to make sure that for the next range that we look at, we keep track properly of what now our last maximum was. And this avoids allocating intermediate, like an intermediate thing, which I think is also, I was quite happy with this. This was actually the solution as I came up with on first shot, and I was like, that feels good.
You would have been prepared for even larger numbers of integer or long ranges. Yeah, definitely.
Because I didn't know.
Yeah, you never know before. Yeah, and yeah, it could have been much harder. Let's see what comes up next days. But definitely, yeah, you don't need the merged ranges at all. You just care for how much did I account for and where do I have to count on. Perfect. Yeah,
exactly.
I'm just wondering, wouldn't it be possible to fold this? I'm pretty sure it would be. The accumulator
it certainly would.
Everything is foldable. By the way, I read this once. Like everything is foldable. Everything. Fold is one of the basic operations. Basically, everything else comes from fold. It's a variation.
I had a user group talk at some point at the Kotlin user group in Munich, which was called "Wait, It's All Fold."
Yeah,
where I derive a bunch of other standard library functionality from fold. So you can absolutely do this with a fold.
Yeah.
I think all the main annoyance here, but again, it's also not particularly a particularly big problem, is that you have two state variables. So you would just throw those into a data class, and you'd have to do a whole bunch of copies of those with the different ones changed. But you could absolutely fold it 100%.
Yeah.
So
Perfect.
So this was a really I was quite happy with this approach. I gotta see the visualization again one more time. It's just so fun. We just squeeze that back in here. There we go. Well, a little further down. I think the part that I think is more interesting with the sorted ranges. It's always kind of what are you maybe also gambling on in the first section, because you might be saying, oh, I see a whole lot of ranges and I see fresh produce. Then I think the natural part 2 actually would have been a bunch of these ranges intersect. Now tell us which of the products are now still considered fresh. Like that would still use the entirety of it. But if you make that assumption and you start like pre-coding a data structure or a setup for intersections already, you're not going to be in luck for this specific puzzle. So that's always a little bit of the trade-off. I did get terrified when I saw the large numbers. I kind of want to have this as like my screensaver or something. It has the same like vibes, the same like aesthetic quality as the defrag tool for sure.
Yeah, absolutely.
Especially with the squares, it's very, very good. Well, amazing stuff. It's a bit of a shame because I think we've reached the end here. I think this might be it. It's a very good time. Thank you so much, Olaf, for joining today's final Advent of Code stream and making it such a good one at that. It was really a pleasure.
You're welcome, and thanks for having me. Really cool.
I'm always impressed by, you know, when I get up in the morning and I do solve the puzzle. Sometimes I'm like, I wonder what it is we're going to talk about tonight, because somehow these things have a magic way of going for an hour. Even when the puzzles are small, even when the puzzles are big, we somehow always manage. And it's always interesting, and I always learn something new. And I hope that everybody back at home is also learning something new. While exactly, and I think the most important thing is all your fold are belong to us. So of course, as the next challenge arrives tomorrow morning in just 11 hours, it might be a good time to always keep thinking about using a fold operation. It might just be the thing that you need. Olaf, do you have any predictions for, well, there's only like 7 days left in total, so I think Eric needs to be a little bit economic with the types of problems that he really wants to see in there. What do you think might be coming up?
I really do hope that it's going to be something very visual and something where you have to think around the corner more than we did so far. So I'm hoping not for a specific puzzle type, but I'm hoping for a twist that makes part 2 somewhat unsolvable in the beginning. So even though I suffer so much when it doesn't work and I don't know what to do, I'm kind of missing it. So I wanna suffer tomorrow.
There is, I think we are all kind of chasing the high of like a real aha moment, of this moment of saying it looks impossible, and then you tilt it, you twist it, you look at it from a different angle, and you're like, I think I have an in. And that's
so my nemesis would be something with the modulos, so the modulo worlds, modulo calculus.
The Chinese remainder theorem stuff is
I always forget this. Every year I'm like reset, and then I have to think about it again. I open Wikipedia, I read about the Chinese remainder again. Maybe something like that.
Yeah, I personally, I hope that one comes far like back on so that I have an even better excuse when I don't touch it, because I I don't enjoy the modulus ones that much.
What was
but
your favorite puzzle in the past 10 years? Do you have one specific that you can directly point at?
There are some that I think just have a really special place in my heart. And there was one where you had, it was, I think, 3D particles that you had to simulate that would then spell out something.
Mhm.
And those that was just mind blowing. I also my nemesis. So I'll be very honest. Like for me, my Advent of Code calendars, they're 100% authentic. If I can solve it by myself, I don't have the star. Which also means that there's a bunch of puzzles that I have not solved. And I think my all-time nemesis is the one where you had a bunch of 3D cubes that were all like overlapping. I think it was maybe something where you had to turn on light bulbs or something using the overlapping cubes, perhaps. Might be misremembering. But that I still think about it sometimes because I was sitting on the floor of my room just doodling, trying to come up with what edge case I might have missed in my implementation because it seemed so straightforward, but there was some deceptive twist that I must have missed. But whenever I get to the best one was or my actual favorite one was the one with the seating chart. Do you remember what that was? I'm gonna briefly.
Seating chart.
Yes. Let me take a quick
Was
look
that a
here.
Game of Life clone? Something with seats in a waiting hall in an airport?
I think it was something where, okay, hold on. Let me see if I can quickly Google this up here on the second side. Advent of Code seating chart. The seating system, was that it? Let me see. I think so. Let me find the. Oh yeah, it was 2020. How do I go to years,
Events.
right?
No, events. Yeah.
Events, and then 2020, and then day 5. Day 5 binary boarding, which was, yeah, and I can also, for anybody who would like to attempt this challenge, I've just linked you an extra challenge for today. This task, it looked like you had to do so much manual stuff, and in the end, when you stare at it for long enough, you realize you're just effectively doing like a like a number system in a different base, and you're just interpreting numbers. And I still remember like the rush of dopamine I got when I noticed this, and it like, yeah, for some reason this was just, it was just burned into my mind. I was like, wait, it's all just numbers. It's fine. I don't have to do all the like crazy stuff. It's like 3 lines of code. So yeah, that is my favorite. I do have this one. I do have this one solved.
Nice.
Do you have a favorite?
Yeah, definitely. So one set of favorites was the int code computer.
Of
That
course.
was a total series that ended in a clone of a game. That was really cool, and I'm absolutely sure, because it took like a week or something, or 7 puzzles in total to build this int code computer. And many people complained about the complexity and that they got lost. So if you didn't do like one day, you were kind of lost doing the next puzzle on that theme. And I fear that was the reason why it never got repeated. But there is a community that really loved that int code computer, and I'm one of those. I would have loved to see more code of that int code computer. I love that very much. Oh, okay, you got stuck there? No, come on.
Listen, it was 2019. I had.
Yeah. That was really cool. But there is another one that really never gets boring. And I'm just looking whether I still have it here. Here it is. I got it next to me on my desk. It's a little bit crumbled, but let me show you this here. Anybody who has done Advent of Code knows what this is. It's a piece of paper that you can fold, and it gets folded into a cube.
Yeah.
Like this here. So you fold it like this. And if you can see this, I got numbers on A, B, C, D, and whatever. So you got something in a 2D plane, and you had to write code that folds this to a 3D cube. And on the surfaces of the cube, there was a maze where something had to find a way and go over the edges of the cube. Such an amazing thing. Unbelievable. It was like I was taking my paper and scissors and doing it live in action to just understand how the edges of the cube fold together and what kind of a translation you have to do if you hop from one face to the other. I love that. Yes, that's the one. And
Very
basically, this is what you see here.
It's I love that you still have that. That's great. It's so good. Oh my.
So I hope that these kind of puzzles come back. At least one of them, please.
I'm sure. I'm sure we'll get some. We'll get some tricky stuff in there at least for one of the days. I have no doubts. Well, I think that concludes the live stream portion of our Advent of Code campaign. But of course, you know where to go to find our leaderboards, to find our templates, to find a good excuse to try Amper in your next project, to find a good excuse to write an AI-based visualization for the puzzles. You know where to go. And of course, we will be continuing to produce wonderful content on our YouTube channel. So in case that button still says subscribe and not subscribed, make sure you hit that button. And if you are still really, really excited about getting some more code, of course, I can once again recommend that you head on over to the videos tab on our channel. You take a look at our latest upload, which is a shortened version of yesterday's Kotlin Notebooks live coding session. If you didn't miss it, that's a really important one because I think it's really, really inspiring. I've already previously linked Olaf's repository as well, in case you want to see what kind of crazy things are a part of his library. However, the disclaimer that Olaf gave still applies. Write your own, so you'll learn something in the process. The next challenge unlocks in 11 hours, so Advent of Code is far from over, and I, of course, hope that you will continue to have a lot of fun writing your solutions in Kotlin and solving those problems. The Kotlin community is, of course, still continuing to also solve their problems, so head on over to our Slack as well, the Advent of Code channel, where these things are discussed every day. And I am repeatedly and often impressed by how short some people's solutions are, by how fast some people's solutions are, and by how seemingly undecipherable some of them are on account of being so clever. Yeah. Thank you, everybody, for tuning into these 5 wonderful streams, and have a wonderful Advent of Kotlin. Take care, everybody. Thank you, Olaf.
Bye-bye. Thank you.